So in this question, the relative permeability, core cross-sectional area, mean core length is given, and we need to calculate flux. We know that flux is equal to mmf divided by reluctance, just like I is equal to V by R. So here we need to calculate first of all the reluctance, and reluctance is just, we know the resistance is equal to rho L by A, or 1 by conductivity L by A. So something like that, the reluctance is 1 by mu into L by A. So now after putting those all values, 25 into 10 to the power minus 2 divided by 4 pi into 100 into 10 to the power minus 7 into 5 into 10 to the power minus 4. So this value will be 3.97 into 10 to the power 6. So what is the value of flux? Flux is mmf, that is 1000. It is given in the question, and divided by reluctance, that is 3.97 into 10 to the power 6. So value is 0.25 milliweber. So our answer is B.
Let us see the content of accumulator after the execution of program. The given information is move immediate accumulator with B8. The content of A is copied to B, that is B8 is copied to B. A content is copied to B. STC stands for set carry, and hence carry flag is 1. After that, CMC, carry flag has become 0, complement carry. RLC indicates rotate the content of accumulator 1 bit left without carry. It means the content of accumulator is B8, 1011, 1000. This without carry indicates that the MSB is copied to the carry flag and also to the LSB. This is least significant bit, this is most significant bit. And hence carry flag was 0, now the carry flag becomes 1, and the same 1 is also copied to the LSB, and all bits are rotated 1 bit towards left. And hence this 1 is replaced in the LSB, and these are 0, 0, 0, 1, 1, 1 and 0. This is the current value of accumulator after RLC. Again complement carry. Therefore carry flag was 1, now it becomes 0. So carry flag is 0. Then again we can write RAL. What is RAL? Rotate the content of accumulator 1 bit left along with carry. So accumulator content was having 7, 1, and this content is rotated 1 bit left along with carry. So carry flag was 1, it was complemented now along with carry. It means that LSB, MSB, if we consider, left direction is from MSB to LSB. Therefore carry is replaced first here in LSB, and all bits are rotated towards 1 bit left. The same carry is also replaced with the MSB. It means that if we rotate this data, this would become 1, 1, 1, 0, 0, 0, and this 1 would come here. It means the content of accumulator is E to H, and hence the option is D.
The equation of the curve satisfying the equation dy equal to y tan x plus secant x dx. Passing through the origin can be given as, okay, first we have to solve differential equation dy by dx minus y tan x equal to secant x. It is in linear, dy by dx plus py equal to q form. Now integrating factor is dy by dx plus py equal to q. So integrating factor is e power integral p dx. So minus tan x dx. Now e power minus integral tan x is log secant x, that is nothing but 1 by secant x. Now the solution is y into if equal to integral q into if into dx. Now y into 1 by secant x integral q is secant x into 1 by secant x dx. Right, y by secant x equal to integral 1 dx is x plus c. given that the curve passes through the origin, therefore when x is 0, y is 0. That's why c equal to 0. Therefore, the equation of the curve is y by secant x equal to x. Therefore, y equal to x secant x is the in this problem we have to apply RK second order method for the differential equation dy by dx equal to 3x plus y square with initial condition y of 1 equal to 1.2, and we have to find out the value of y when x equal to 1.1. So initially when x is 1, the value of y is 1.2. We have to find out the value of x at 1.1. Now step size 0.1. Function of xy is 3x plus y square. Initially x naught is 1, y naught is 1.2. We have to find y value at x equal to 1.1. Now take step size 0.1. To apply RK second order method, first we have to find k1. k1 is h of function of x naught y naught 3x naught plus y naught square. H is 0.1, 3 into x naught is 1, y naught square is 1.2 whole square. By simplifying this, we will get 0.444. Next, we have to find k2. k2 is h of function of x naught plus h, y naught plus k1, that is h of 3 into x naught plus h plus y naught plus k1 whole square. By substituting and simplifying this value, we will get 0.600. Now k is k1 plus k2 by 2. Now that is 1 by 2 of 0.444 plus 0.600 by 2. Next y1 is y naught plus k, that is y naught is 1.2 plus 1 by 2 of this value 0.444 plus 0.600. By simplifying this, we will get 1.722. That is the value of y when x is 1.1.
In this question, we have been given a RL series circuit. Suppose it is B and it is R, it is L, it is RL series circuit and a current I is flow. Also given V is equal to 100 volt, R is 50 ohm, L is 10 Henry. Then we have to calculate the time at which the voltage drop across R and L are same. If we want to calculate current I, it can be written as V, that is this voltage upon R, 1 minus e to the power minus t upon tau. V is 100 upon R, that value is 50, 1 minus e to the power minus t by tau. Tau can be written as L by R. So L is 10 by 50, that is equal to 1 by 5. So it is 1 by 5, that is minus 5 t. This value can be written as 2, 1 minus e to the power minus 5 t. This is the value of current. Now the voltage across R, VR, can be written as R into I. That is, R value is 50. So 50 into 2, 1 minus e to the power minus 5t. That is, VR is equal to 100, 1 minus e to the power minus 5t. And VL value, voltage across inductor, is equal to L di upon dt. So now VL can be written as L value is 10 into di upon dt. If you differentiate this, so this will become 0 and 2 and this 5, 10. So 10 e to the power minus 5t. 100 e to the power minus 5t. According to the question, we have to calculate the value of time when both of these are equal. That is, VR is equal to VL. VR will be equal to 100, 1 minus e to the power minus 5t is equal to 100 e to the power minus 5t. On solving t value would be equal to 1 by 5 ln 2, and this comes out approximately equal to 0.14 second. So answer for this question is approximately 0.14.
Block diagram representation of a system is given, from which open loop transfer function is k ts plus 1 upon s square s plus 1. The above system is said to be stable for what values of k, where k is given to be greater than 0. Question is to find the values of t for the system to be stable. Characteristic equation of the system is s cube plus s square plus kts plus 1 is equal to 0. Once the necessary condition is satisfied, that is, all the coefficients of the characteristic equation are present and have same sign, the sufficient condition for a third order system to be stable is the product of these two coefficients must be greater than the product of these two coefficients. That is, kt must be greater than 1. Since k is mentioned to be greater than 0, now t has to be greater than 1 is the answer to the question.
The next question, we have to calculate value of this integration. Now this integration is related to impulse function delta tau plus 3, and if we will draw the waveform for delta tau plus 3 with respect to variable tau, then location of impulse will be at tau equals to minus 3. Now the range of integration is 0 to infinite, and in this range, in the range 0 to infinite, nature of or value of this delta tau plus 3 is 0. So in the given range of integration, value of delta tau plus 3 is 0. Therefore the value of integration will be also 0.
In this question, the ratio of a starting torque to maximum torque is given, that is 0.8. So from this relation we can calculate the slip at T max, that is 2 by slip at T max divided by slip at starting plus slip at starting divided by slip at T max. So from here slip at starting, the value is 1. So just with the help of this expression, slip at T max is nothing but basically 0.5. Now the speed at maximum torque is equal to 1 minus slip at T max into ns, and ns basically is 1500, it is given. So from here this value will be 750 rpm. So our answer is 75.
This question is about finding current through T5, which is denoted as I5, and the data given here is all transistors have a very high beta, so we can ignore their base currents, and the other data given is T1, T2, T3, T4, they are of equal size, and their area is 2 times the area of T5. Now what I observe first here is T1, T3 are in series, so because of series connection their currents will be equal. I3 same as I1, and that is equal to 5 milliampere. And then T3, T4, they will be having perfectly equal VB because their base is shorted and emitters are also shorted. Now if two transistors identical and if they have perfectly equal VB, then their currents will be equal. So current in T3, current in T4 will become same. I4 equal to I3 equal to 5 milliampere. Now in case of T5, the difference is it has an area half that of T3 and T4. But VB will be same, VB5 same as VB3 same as VB4. But because area is half in T5, current in T5 will be half, because the property in transistors is current proportional to the area of emitter junction. So if cross section area is half, current in T5 will be half. So if I write here I5, that I5 will be equal to I3 divided by 2. That I3 divided by 2 means it will be equal to 2.5 milliampere. So in this question, transistor T5 will have a current equal to 2.5 milli.
We are looking here a digital to analog converter of weighted type. The given circuit is weighted type digital to analog converter, and logic 0 voltage is 0 volt, logic 1 voltage corresponding to logic 1, the voltage level is 5 volts, and we want to have the step size is to be 0.5 volts. What is the RF, the resistor which is used in the feedback circuit of op amp? What is the RF? It is the question, and we are looking based on this. It is a 4-bit weighted type digital to analog converter, and the resistor corresponding to MSB bit, the resistor value corresponding to MSB bit is 1K, and in the description it is mentioned the resistor R0 is corresponding to LSB bit. So the R0 supposed to be to the power of 3 into 1K, so that we are looking, this is coming to be 8K, and the step size is equal to minus of the voltage corresponding to the logic 1 into RF divided by R0. So it's a formula. So if you substitute the values here, this is minus 5, RF we need to calculate, and R0 is 8K, and step size we are looking as the given data minus 0.5 volts. So that to evaluate this for RF, RF will be reading as equal to 800 ohms. So ohms.
Here is asking us to calculate the percentage error in the reading of the energy meter. We will first start calculating the value of the energy consumed. The value of the energy consumed in this case can be written as energy consumed by the load is going to be equal to V into I into T. The value of V he has given as 200 volts into the value of I he has given as 60 amperes into T is 42 by 3600 hours. 42 divided by 3600 hours. The value of the energy consumed in this case is going to be equal to 0.14 kilowatt hour. Now, the meter constant of an energy meter is defined as the number of revolutions that the energy meter's disk makes per kilowatt hour of energy consumed. So, for 0.14 kilowatt hours of energy consumed, we will calculate the meter constant for this particular load now. So, for meter constant for the given load, for I would rather say the calculated load, this is going to be meter constant K dash is going to be equal to number of revolutions divided by the kilowatt hour. Number of revolutions he has given as 60 divided by the energy we have just calculated as 0.14. 60 divided by 0.14 in this case is going to be 428.57. 428.57 revolutions per kilowatt hour. But what is the actual measure energy meters, actual meter constant of the energy meter given as? The meter constant, the actual meter constant will be K. This has already been given as 460 revolutions per kilowatt hour. So the error is going to be equal to, therefore, percentage error is going to be equal to measured value minus true value divided by the true value into 100, which in this case, this is the true value and this is the measured value. So K dash minus K divided by K into 100, this is going to be, what is the value of K dash that we have calculated? It is 428.57 minus, given is 460 divided by 460 into 100. Upon calculating, this value is coming as minus 6.83%.
In this problem, given that the radium decomposes at a rate proportional to the amount present, 10% of the original amount disappears in 50 years, then the amount remaining after 200 years will be dash percentage of original amount. Initially, when time t equal to 0, suppose the amount is x. After 50 years, 10% disappears. Therefore, 0.90 is left. 0.90 of x, 90% of x is left. From 50 years to again 100 years, again 50 years. So if you say this is y, then 0.90 y is left. It is nothing but 0.90, y is nothing but 0.90 x. This is remaining. Now, from 100 years to again 50 years means 150 years. This amount, suppose if you say Z, the remaining amount will be 10% disappears from Z, therefore 0.90 Z. It is nothing but 0.90 into 0.90 into 0.90 of original amount x. Again from 150 years to 200 years, again 50 years, then this will become 0.90 whole power 4 of x. That is nothing but 0.6561 x. Therefore, 65.61% of original amount is remaining. In this problem, we have to find out angle between normals to the surface xy equal to z square at the point 412 and the point 33 minus 3. Now, phi is xy minus z square. Now, grade phi I bar del phi by del x, j bar del phi by del y, k bar del phi by del z. That is I bar of del phi by del x is y plus j bar of del phi by del y x, k bar of del phi by del z minus 2z. Now, a bar is grade phi at 412, that is I bar plus 4j bar minus 4k bar. B bar is nothing but grade phi at 33 minus 3. Now, 3 I bar plus 3 j bar plus 6 k bar. Now, cos theta is a bar dot b bar by mod a bar into mod b bar. I bar plus 4j bar plus 4k bar dot 3i bar plus 3j bar plus 6k bar, square root of 1 plus 16 plus 16, square root of 9 plus 9 plus 36. By simplifying this, 3 plus 12 minus 24 by square root of 33 into square root of 54. By simplifying this, you will get minus 0.213. Therefore, theta is cos inverse of minus 0.213, which is equal to 102.31 degrees.
In this question, we have been given this network and we have to calculate BA and RA. BA and RA are nothing but the BTH and RTH. So we have to convert this circuit into equivalent, Thevenin's equivalent circuit. Now, if we apply mesh analysis in this, so we have 2 into 10 minus 2 into 10 to the power minus 3, 2 millivolt, plus 2 into 10 to the power 3 into I1 plus Vx upon 5000. This is equation number 1. If we apply KVL here, so Vx can be written as, from this, Vx will be equal to minus 100 I1 into 20 into 10 to the power 3. So we can calculate I1 is equal to Vx minus sign and 2 into 10 to the power 6. Now we can calculate Vx value by putting this into equation 1. So we have minus sign this side, so it is 2 into 10 to the power 3 is equal to 2 into 10 to the power 3 into I1. I1 value is minus Vx upon 2 into 10 to the power 6 plus Vx upon 5000. So if you solve, you will get Vx and that Vx is equal to minus 2.5 volt. And this Vs is equal to V open circuit voltage, that is VTS, because no source is connected here, no load is connected here, nothing is connected here, it is open circuit voltage. Now to calculate RTS, let us calculate the short circuit current. So short circuiting this voltage source, this terminal A and B, it is ISC. If you short circuited this becomes dead, a short circuit. So ISC will be equal to minus of 100 I1 first. Now we are wanting to calculate I1. We have short circuited Vx terminal, so this voltage is also short circuited, dependent voltage, and this I1 can be calculated. I1 is equal to 2 into 10 to the power minus 3 divided by 2 into 10 to the power 3. So it is 10 to the power minus 6. That is the value of I1. And if we put this value of I1, then ISC will become minus 10 to the power minus 4. 100 minus 4. This is the value of ISC. So RTH will be equal to VOC, that is minus 2.5 volt upon ISC minus 10 to the power minus 4. If you solve this, it comes out to be 25 kilo ohm. So answer for this question, VA will be equal to minus 2.5 volt and RA, which is RTS, is equal to 25 kilo ohm. It is given in option D. So our right choice for of answer for this question is option